This is an example project by me, Dr. Heitzman. I'm going to use calculus arc length to find the length of a path or loop on a map modeled with a function. This project was completed at Bergen County Academies for the AP Calculus AB class section's third trimester project in 2016. All paths and loops and videos of the corresponding math used to find arc length are drawn on and updated to a shared Google map. After I decided to do a portion of the Saddle River pathway and found the portion I wanted to do on the map, I traced out that portion with the Draw a Line button. In addition to my pathway, I traced out a rectangle using the same line, which I will erase later. The left vertical and bottom horizontal lines will serve as my y and x axes respectively. Their intersection will be my origin. I also added a marker and named the pathway and marker Heitzman. To find coordinates for the points on my curve, I clicked first on the ruler button and then on the name of my loop, Heitzman. I clicked on the origin and moved a portion of the distance along the x-axis. I clicked again, taking note of the distance. This is my x-coordinate. Then I moved in the y direction, creating a right angle, until I reached a point on my path where I double-clicked. The y-coordinate is the total distance minus the x-coordinate. I repeated this process and found coordinates for 12 points, approximately evenly spaced along the x-axis. They're shown in this table. To enter the coordinates on my graphing calculator, I went first to Stat and then to Edit. I entered my x values in the L1 column and the corresponding y values in the L2 column. To view these points, I pressed Second and then Stat Plots and clicked on Plot 1. From this menu, I chose On, the scatter plot icon, L1 and L2 for my X and Y lists respectively. To view my points on my graphing calculator, I simply pressed Zoom and then chose 9 for Zoom Stat. At this point, I wanted to fit my points with a function. I predict a cubic function will fit the points well. So I click on Stat, Calc, and then Cubic Reg for a cubic regression line. This function can take 2 or 3 arguments. I will use 3, separated by commas. The first 2 are my x and y coordinates, second L1 and second L2. For the third, I want to give the location for the resulting fitted function. I click on vars, yvars, 1 for function, and then 1 for y sub 1. When I press enter, I see the screen shown on the right. It shows a cubic regression with the general form y equals ax cubed plus bx squared plus cx plus d, and the corresponding values for the coordinates a, b, c, and d. Finally, I want to find my arc length. My lower and upper limits are the x values 0 and 202, and I let the calculator do all the work. I used Math 9 to get the template for a definite integral. I filled in the appropriate limits and used the formula for arc length, the integral of the square root of 1 plus the derivative squared. For the derivative, I embedded the template for the derivative using Math and 8. I used x equals x instead of a specific value. The value of x will change gradually from 0 to 202 as the calculator evaluates first the derivative and then the section of the arc length for each new x value. It then adds all these up and gets a total arc length of about 399. Now I erase the rectangle around my path by clicking with the right click on the mouse and erasing the points I no longer want. The map calculates that my path is 417 feet long, which is close to my calculation of 399. Then I made the PowerPoint recording and uploaded it onto the map. Thank you.